Morning, students. I invite Deepashri ma'am to start the session.
Good morning. Am I audible? Am I audible?
Yes, ma'am.
Okay. Yeah, so is my screen visible? I guess my screen is visible. So, do you remember where we stopped in the last class? Okay. So, today we will be starting with the calculation of work. That is the work calculation for first law of the thermodynamics. So, okay. So, I have drawn this and let's start with the work. So for work, we always write like this is for your boards. Like dW, it is F of external dx. Okay. So again, F of external can be written as into A dx. This is equivalent to pressure, this term. If you are doing physics, so you will be knowing that this is external. Okay. And this is the definition for volume. Okay. So So, okay. So this is the basic derivation for work done in the process of the thermodynamics. If they ask you to calculate the work in your book, do this entire calculation. Okay. Now, what is this? This is applicable for all kind of the process and for all types of the fluid in closed vessel. So what I told that this is applicable for all types of the process, for all types of the process. All types of the process and all types of the fluid. And all types of the fluid in closed vessel. Okay, so this is the basic concept. This is the formula for work done, and this is something that we get. I forgot to draw. Here we are applying a pressure. Okay, and this is the any kind of the liquid inside the vessel. Okay, so this is the standard derivation. Now, what will come in our exam? In your Neet or anything, they will ask if this is the conclusion that we can draw. P external is equal to 0. Free expand expansion will occur. Okay, so this is the standard. Then what will, how the formula will look like? So if P external is 0, then we will be using this formula. If process is irreversible, then P of the external becomes a constant. So keep this in mind. Okay, in the last page, these are Okay, this is external. Okay, so these are the different formulas. This is the standard formula, and these are the different conditions. If it becomes zero, then we will be using this formula. If the process is irreversible, then we will be using this formula. Okay, so what will happen here? What is the standard formula? W is equals to minus of P external integration of minus of P external V2 minus V1. So this becomes the formula. This becomes the formula for what? When the process is irreversible. Now you can ask me that if the process is reversible, what will happen? If the process is reversible, what will happen? Then W will be equal, then P of the external So if the process is reversible, then whatever is the pressure of the gas, same will be the pressure, same will be our external pressure. And that for gas, we know PV is equal to nRT. So for P, that will be equals to nRT by V. So this is the thing we will be using. Now, how to incorporate it in the work formula? So work will be minus of P external dV, which will be equal to minus of V1 by V2 nRT dV by. So work will be finally equivalent to V1 by V2 nRT dV by. Okay, so anything they will be asking you about this concept. These are the formulas. Okay, in your exam, they can either ask you that if it is an external process, among the four formulas, which formula will be the correct one? Or they can give you some values, that value, how to calculate these values, that you will be learning in the integration classes in your maths. Okay, but this is the formula, how to solve the integration and all, that you will be learning in your maths class. So this is the different conclusion and the different formulas. I have given you a set of the examples. So these are the standard formulas that you should deal with. Okay. Now there is some another conclusions. Area under the PV curve. Area under PV curve gives magnitude of work done. Okay, this is very important. So this is our work done. Okay. So the area under PV curve gives the magnitude of work done. So this shaded area is magnitude of work done. Okay, done. Next conclusion. Okay, now I will be teaching you, now I will be giving you some questions. Let's solve the numericals that usually come from here. So the first numerical, calculate work done. Calculate work done for expansion, for the expansion of a substance 3 meter cube to 5 meter cube against number 8, constant pressure. Only variables. Number C, free expansion. Number B for 1. Now try and solve this question first. Try and solve this question first. Okay, something I need to tell you, I forgot to tell you. I'm writing the one more condition here, okay? After this, learn this. Okay, there is something another. If pressure is function of volume, example, P is equal to A plus BV, then work done will be minus of V1 by V2, A plus BV. Okay. Now try and solve this question. Just try and solve. I will be doing, but first just try and solve this question. Try. I will give you 3 minutes. No? Okay. I'm doing one for you. What is this? The volume has changed, right? This is volume V1, this is volume V2. So let's just do this now. So for this, how to solve? Volume change is what? What is the basic formula for work done? For work done, what is the basic formula? Work done is equals to minus P delta of V. This is the standard formula. Now, what is delta of V? Delta of V means V2 minus of V1. What is V2? 5 minus what is V1? 3. Something meter cube. So what is this? 2 meter cube. Okay. So what is the pressure? Pressure I have given as 10 to the power 5. So 10 to the power 5 of 2. So it is minus 2 into 10 to the power 5 joules. Is this part clear? Is this
Yes,
part
ma'am.
clear?
Yes, ma'am.
See, use the basic formula and do it. So try for variable pressure. For the variable pressure, do it. Use this formula. I've given this hint also. This formula you should be using. It's easy. See, for the variable pressure, you will just write like this. It is 10 because the pressure is given as 10. It is a function of volume, right? So 5 times of the volume. So what is this? This will give you minus 10 into 2 plus of 40. Whatever it is coming, that will be your answer. So why we have done this? Because it is not a straight equation, right? So this equation, this is the, so V delta V is equal to 2. Here I have already shown you. Okay, so, so that is coming from here. Okay, so these are the type of the examples that you can expect in your exam. Okay, for free expansion, what is there? Free expansion. So the answer will be 0. Okay. So these are the type of the questions from the work done that you can expect in your NEET. As simple as that. Okay. Just remember the graph, remember the conclusions, and accordingly try solving your questions. Okay. And for this, since it is written here 4, and what is the equation? Minus 4 nRT, right? But here it is written as 4. So that, yeah, so that will be given as like this. This is the change in volume. So whatever they are asking you, accordingly change the formula and write the answer. Okay? I guess this part is clear for you. Okay, now I have to teach you something. Another derivation for the part of the thermodynamics that may come in your books. Derive an expression for work done for n mole of van der Waals gas. Van der Waals gas means a gas with a constant temperature. Okay. So if this is the question, how to do this? For van der Waals gas, remember that the formula PV-nRT changes. So the formula becomes P plus N square by V square into V minus NB is equal to nRT. Okay. So from here, what we can write? P is equals to nRT divided by V minus NB. So we can minus N square divided by V square. So from here, we can write this. Again, what we know for work done, the formula is this. So just replace the value for P. nRT by V minus NB, that dV plus integration of V1 by V2 N square by V square dV. So from this, what you will get? Minus nRT ln V2 minus NB by V1 minus NB minus N square 1 by V2 plus 1 by V2. This is another derivation, which is formula you have to remember for your Neet, but derivation you have to remember for your boards. This is for van der Waals gas. Okay, this is strictly for van der Waals gas. Okay, now let's do the unit conversion. Unit conversion. What is this? 1 bar liter is equivalent to 100 joules, and 1 atomic liter is equivalent to 101.3 joules. Okay, so in your exam, they will be asking you about bar liter or atomic liter. So where to use 100.1 and where to use 103, 100 and 103, that I have given. So if in your numerical it is 100, then write this. If it is in atom, write 101.3. Okay. So these are the basic things about the work done. So for work done, is there anything you have to ask me? Or is there everything clear to you? Then we will be starting with the heat. Okay, so next quantity is our heat. So what heat? It is the transfer of energy due to energy difference, right? Transfer of energy due to energy difference. Due to energy difference. So it is also neither an intensive property nor an extensive property. Neither intensive nor it is an extensive property. And also third quality is it is a path function. So these are the basic qualities for heat. So for sign convention. Sign convention. What is the sign convention? Heat lost by the system. Heat lost by the system will be considered as negative, and heat gained by the system, that will be taken as positive. Okay, this is the simple thing. Now, next comes heat exchanged at constant volume. Heat exchanged at constant volume. QV. Okay, for heat, the sign is Q. Okay, so heat at constant volume will be written as QV. That will be equal to del U, and heat exchanged at constant pressure. So what will be the formula? QP is equal to del H. So these are the standard conventions that we use for heat in chemistry. So dq, again, this is something I am doing for your boards. dp is equals to ncm dt. This is another expression for heat. So dqv, that is the heat at constant volume, that will be equivalent to n cv m d. So dqv by dt, I'm taking this dt here, that will be equal to NCVM. If you are studying and revising, you will know that this is the expression for CV. Okay, so from gas, before starting the first law, we have done that this is the expression for CV. So I told you that dQV at a constant volume is represented as du. So du by dt, what? At a constant volume will be equal to NC, not N like this. NCVM, which is equivalent to CV. So similarly, what I can say, dH by dt at a constant pressure will equivalent to NCPM, which is CP. So for volume, it is CV. For H, it is CP. Okay, so for U, it is CV. H, it is CP. So this is another important derivation. So what is U? U is the internal energy. Internal energy. In some books, you can see that instead of U, they have written it as E. Okay, so U or E both are the same thing. So this derivation may come in your boards, but the conclusion is important for your Neet. Like du by dt at a constant volume is CV and dH by dt at a constant pressure is CP. Is this part clear? Because in your exam, they will be giving you 4 options and the question can be coming like, what is the constant what is the heat at a constant volume is equivalent to CV? So they will be giving you 4 options and you accordingly you have to choose. So if they ask you that the Q at a constant, like the heat at a constant volume, what is the expression? This. Heat at a constant pressure, what is the expression? This. Is this part clear how you will be getting question and how you will be solving the question? So next start with the internal energy. Internal energy. Internal energy is U or A. Okay. So what is this? It is the summation of all kinds of the energy. Summation of all kinds of energies present in the system. Okay. So U is equivalent to kinetic energy, potential energy, and these are the different forms of the energy. Okay, so these are the all different forms of negligible effect of change. So basically, this is the summation of all kinds of the energy. So we cannot, one more thing you have to remember, we cannot remember the exact value. Not remember, we cannot calculate. We cannot calculate the exact value of U. Why? Because it is an extensive property. And it is a state function. These are the numerical types of the question that you can expect in your boards. Numericals of your boards. Okay, so be very careful. So that's why we can't calculate. And in thermodynamics, we consider system at rest and accept gravitational fields, and all other fields are assumed to be absent. Okay, we only consider the gravitational field. Rest is change. So in thermodynamics for chemistry, in thermodynamics, remember this, in thermodynamics, we consider system at rest and accept gravitational fields. All others are considered to be negligible. All others will be considered to be absent. Okay, so these are the different properties while solving the questions from internal energy. Now, if internal energy, first criteria, if internal energy is changed, what will happen if the internal energy is changed? We know it is the summation of kinetic energy and change of the potential energy. Change of potential energy. This is the standard definition for internal energy. Now, in case of an ideal gas, there is no interaction between the properties. So for ideal gas, there is no interaction between particles. So for ideal gas, what will be the condition if there is no movement? Potential energy will be zero. So therefore, there will be no change in the potential energy. So delta of potential energy will be zero. So for ideal gas, what will be the condition? Delta U is equal to delta E. Okay. So what is this delta E? Not delta E, sorry. It is the kinetic energy. Okay. So is this part clear? And kinetic energy will be function of a temperature only. Okay, so this is for ideal gas only. Okay, so you wait. So for ideal gas, you will be function of T. Okay. So this is just for ideal gas. From here to here, it is the condition for ideal gas. Okay. So for ideal gas, this is the condition. For another example is that for an ideal gas, U is a function of temperature only. Okay, this T is temperature, okay? Not time, this is temperature. This is the temperature only. And for real gas, wait. But for real gas, there will be interactions. Okay, between particles. So for real gas, delta of potential energy will not be zero. And their potential energy will also be not be equal to zero. Okay, so this is for real gas. So for real gas, delta U will be kinetic energy plus potential energy, and this condition will not be hold for real gas. Okay, so for real gas, U will be the function of pressure, volume, temperature, all three U will be the function. So in case of gases, if the equation of the state is known, then the state parameters can be determined using the two variables, right? So what I told that for gases only. So for gases, if equation of a state, like it is real gas or an ideal gas, equation of a state is known, then state parameters can be determined using two variables at same time. Okay, this is one of the very important property, like U is equal to function of, suppose pressure and volume, T is kept constant, or U is a function of pressure and temperature, volume is kept constant, or it is a function of volume and temperature, P is kept constant. So these are the different things for the real gases. And for the ideal gases, if the internal energy is changed, okay, so these are the different conditions. Now let's do a derivation for ideal gases. So for ideal gas, du by dV at a constant temperature is equivalent to 0. Because I told you that the potential energy part will be 0. So obviously, U at a function of T, that will be also be equivalent to 0. Du by dP at a constant temperature, it will be equivalent to 0. And du by dt at a constant volume, that will be equal to n CVM, which is CV. This derivation we have already learned, but this is for an ideal gas, so this two will vary. So this derivation is already done. So always remember this. This is very important. Okay. So up to this, is this part clear to everyone?
Yes, ma'am.
Okay, good. Okay, I'm doing in the next part page. So we know that what is that? That U is a state function, right? U state function. We know this. So du dV by P dP is U, okay? Constant volume, something dP plus du dt constant volume. This will be equivalent to dt. I told you what? This will tend to 0. I already told you in the last page. Okay, so just now we have told that for an ideal gas that will tend to 0. So this will be tending to 0. So what is the formula we will get? What is the final formula that we will get? That is so this is our formula. This integration part, don't worry, that you will be learning in your maths class only. But this is the formula. I am teaching you where to use what formula. In your Neet, if they make you the question paper difficult, they, up to this is present in your book. But if CV, sorry again, if CVM is independent of temperature, I have seen this question in the previous year questions of Neet. Okay, so if this is the condition, then delta U will be N CVM T2 minus T1. Just anything I am telling you. If anything, see here, T is constant here, right? So if anything that is asked you that is not constant, whole thing will remain same. For this, that will be just the change in temperature. Okay, this will be just the change in temperature. Is this part cleared? This, they have just changed this part. I don't think above this part they will make the question difficult. This is the maximum I can imagine. Okay, so this is for an ideal gas undergoing any process. So let me write this. This is for an ideal gas. This is number 1. So for an ideal gas undergoing any kind of process. Okay. Just wait for once. Okay, in the last question, last example, we will be, remember, we are, all three are correct, okay? All three are correct. But this is maximum used. Maximum use this. Okay, all three are correct, but this is the maximum used. So instead, you already know that U is a state function. So instead, don't write this. Just write for an ideal gas undergoing any process, or ideal gas undergoing any process. Undergoing any process. Okay. So this is the basic thing you will be doing only for ideal gas. And what we are doing here, we are calculation of delta U. It is U for physical process. We have already done for ideal gas. Now let's just do for real gas. What will happen for real gas? Now real gas undergoes different process. Suppose real gas is undergoing isochoric process. Isochoric process. Why I am saying isochoric process, real gas? Because in your Neet, you will see this kind of terms only. That you will see this kind of terms. Right. You will be seeing this kind of terms, real gas, isochoric process, then calculate the internal energy. Then what formula you will be using? This formula. Is this part clear? If in your question, they ask you that real gas is undergoing isochoric process and these values are given. In your example, these values will be given. This value, this value, this value, this value, this value. This you can already calculate from degrees of freedom, the number of moles. These all values will be given to you. You just need to integrate. You just have to integrate. Now, why I am not teaching you integration here? Because integration is a huge chapter. Okay, in your maths, you will be learning integration. All these values will be given to you in your exam, and they will be saying a real gas is undergoing an isochoric process. Calculate the internal energy for the system. Will you be able to calculate if they ask you like this? Will you be able to calculate? Now, you already know the formula. Yes or no? Reply. Just answer my question. Can you do this? Hello? Am I not audible?
Yes, ma'am.
So can you do this in your exam? If they just ask you that this is a real gas and isochoric process, then will you be able to solve? This is just the
ma'am.
Okay. So this all will be given. You just need to calculate and solve. Okay. So now coming to the final parts. So what is this for solids and liquids? If they ask you for solids and liquid, this is very rare. This kind of question is quite rare to find. So for solid and liquid, change in volume is negligible. Change in volume is negligible. So d of u will be equivalent to 0. So what will be our formula? Everything will be given. You just need to calculate and solve. But just remember, for solids and liquids, this is the condition always. Okay. Now, this is the last thing I will be saying. So for a real gas undergoing any process, for a real gas undergoing any process, du this becomes the formula. Is this part clear to everyone? I am giving you a homework. Do this in your home. If you have understood, then do this. It is So solve this question and we will be discussing it in the next class. Okay. Clear?
Yes, ma'am.
Take a screenshot of this. Solve this. I know thermodynamics is an extremely boring chapter, but I can't help. I am writing as far as I know so that you just see the, okay, if this is the condition, we have to use this formula. If this is the condition, we will be using this formula. Okay. So I am just teaching you like that. I know thermodynamics is an extremely boring subject, but okay, it is in our syllabus, not only in chemistry, in your physics also. Okay. If there is any problem, you can ask me. Okay. Done. Okay then. Okay. So in case of any doubts tomorrow, okay. Okay. So ma'am, this is done from my end.
Students join the next session.